Oh, okay.
Good evening, sir.
Yeah, good evening, Shivansh.
Good evening, sir.
Good evening, ma'am. Good
Good
evening.
evening. Yeah, good evening, everyone. So, I think someone was asking for the revision of electricity. So, we'll just have a revision of electricity. We'll do some portions from electricity.
Sir,
Not yes.
I have a doubt in light.
Okay. So, what's your doubt? Share it.
Sir, can you explain the Snell's law?
Okay. Snell's law. Fine. 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 Let's continue with this Snell's law. Today is our doubt session. Whatever you have doubts like from electricity or wherever, you can ask. Yes.
It is
Okay, see. Ah. So Snell's law, it states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. So for a given pair of media, it states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. Okay. Now see where does refraction occur, where is the angle of incidence and where is the angle of refraction. So for this, we consider here a pair of media. So let's say this line AB be the interface between two media. This is your AB. It is an interface between the two media. Let here you have the medium 1 and here you have medium 2. So as we know that light travels in a straight line. So consider a ray of light traveling through medium 1. Okay. So a ray of light traveling through medium 1 enters medium 2 obliquely. Okay. It's entering obliquely. It's not entering with a normal incidence. So if you want something like normal incidence, so let's make here an angle of 90 degree, which will be the normal to the surface. So this line, the blue line which I have drawn, this is the normal to the surface at this point of incidence. So I got this as the normal. Now the ray of light which is passing from here, this ray of light, when it passes from one medium to the other, it bends. Okay. So depending on their refractive indices, like suppose the ray of light bends something like this. So here we have the bending of light something like this. the ray of light should have traveled straight, but we observe that the ray of light has bent by a small angle. So here this is our angle of incidence, and this one, the angle found between the normal and the refracted ray is the angle of refraction. So the angle of incidence is the angle between the incident ray and the normal. The angle of refraction is the angle between refracted ray and the normal. So refractive index, we say refractive index of medium 2 with respect to 1. The light was coming from medium 1 and it is entering medium 2. The refraction is occurring in medium 2, or we also say that the refracting medium is medium 2. So here the refraction is occurring in medium 2. Hence we will say that the refractive index of medium 2 with respect to 1 will be equal to the ratio of sin I over sin R. Sine of angle of incidence to the sine of angle of refraction. And since refractive index is also given by the formula V1 by V2, where V1 is the speed of light in medium 1 and V2 is the speed of light in medium 2. So you can say that the refractive index of the medium medium 2 with respect to 1 is equal to sin I by sin R. So this is as per the Snell's law we got refractive index is equal to sin I by sin R. This is the statement of this. Okay. See, some certain questions may come with relating to mathematics a little bit from here, but up to now in the board exams they haven't been asked like this. Now, is there any other doubt from this topic? Or is the doubt clear?
No, sir. Doubts clear.
Okay. See, you need to identify the angle of incidence. You need to identify the angle of refraction. Okay. Then you'll get the ratio of sine of angle of incidence to sine of angle of refraction as a constant, which will be equal to the refractive index for the given pair of media. Anyone else having any doubt? Okay, see. When the ray of light coming from glass is incident on a surface at an angle of incidence (60°). It refracts the light by angle of refraction as 45°. Okay. So you have to find the refractive index. Find the refractive index. Can you find the refractive index now? Yes, everyone there? There, Shubhansh?
Sir, yes, sir.
Yes, can you find the refractive index?
Uh,
Okay, in your math, have you done trigonometry?
yes, sir.
Yeah, so try to do this. All of you try to do this question. Shubhansh, Avinav. So you have a ray of light which is incident at an angle of incidence So here the angle of incidence I is given as 60 degree and the angle of refraction is given as 45 degree. So can anyone tell the refractive index?
Sir, 1 minute. Sir. Sir, root 3/2.
Is it root 3 by 2? Check it once
Root
more.
3 by root 2. Root 3 by root 2.
So refractive index will be given as sin 60 over sin 45. So sin 60 is root 3 by 2 divided by sin 45 which is 1 over root 2. Right. Divided by sin 45. So that's divided by 1 over root 2. You can get it root 3 over 2 multiply root 2 over 1. So you get root 3 by 2. Root 3 by root 2. So root 3 is 1.732 and root 2 is 1.414. Got it? You can obtain the refractive index as say 1.732 by 1.414. Yeah, the refractive index you get as 1.22. Got it, everyone? So these are the simple questions which can be based on the refractive index. Now let's do one more question based on this. Okay, so see one more question. Some simple questions can be like this. A ray of light is incident at 30 degree on an on a glass air interface. A ray of light is incident at 30 degree on a glass air interface. It refracts by it refracts so that angle of refraction is 90 degree. So find the refractive index. Yes, find out the refractive index again. Everyone, Shubhansh, everyone should tell the answer now. Don't be idle. Be an active participant.
Sir,
Find the
1 by
refractive.
root 2.
How much?
1 by root 2.
1 by root 2 or 1 by 2?
1 by 2.
Let's check it. Sine 30.
1 by 2. 1 by 2. 1 by 2. Yes, sir.
Okay. So the refractive index is 1 by 2. And also see, it is the refractive index of air with respect to glass, you can say. So you are getting refractive index of the material will be, or refractive index of air with respect to the material to be equal to sine I by sine R. So here you get sine of angle of incidence, which is sine 30 degree divided by sine 90. So sine 90 is 1, you get sine 30, which is 1 by 2. Okay. Can anyone tell when the Snell's law are not applicable? When can we say that the Snell's law is not applicable?
Sir, when angle of incidence is equal to 0.
When angle of incidence is equal to 0.
Yes, sir. When angle of incidence is 0. Okay.
When angle of incidence is
0, then it is not valid.
see, you can say either the angle of incidence is 90 degree, that is the time. Oh, sorry, angle of incidence is 0 degree, that is for normal incidence. If a ray of light is incident normally, then the Snell's law are not applicable. Any other doubt from the chapter light? If anyone has any doubt from chapter light, can ask. Yes, any doubts?
No, sir.
Okay, so I think light chapter is quite clear to everyone. Let's see. Okay, now any doubt from human eye? I think human eye or chapter also we have revised it thoroughly. Is there any concept-based question from chapter 1? Light. Okay, let me say take some questions from chapter light. Okay, have you checked your latest sample paper issued by CBSE? Yes, have you seen the latest sample paper issued by CBSE?
No, sir.
No.
No, sir.
Okay, CBSE has issued your sample paper for class 10. I will be sharing it in the group so that we can discuss it later. Just 1 minute. I'm sharing a few PDF. We'll discuss those. Just 1 minute. I'm sharing in the group. Okay, see, so you have this. You can check the group, it's available there. I've sent it. Okay, I'm sharing it here also. This one is the NCRT exemplar exercises.
Sir, is this on the CBSE website? Like,
No, this one is the NCRT exemplar.
oh, okay.
Okay. The exemplar questions have something extra, so that's why we are doing those exemplar questions. Okay, so see. First of all, which one of the following can make a parallel beam of light when light from a point source is incident on it?
Sir, A part.
Yeah, a concave mirror as well as a convex lens. Both of them has the converging capacity. So they can converge or they can bring it parallel, both is same. Second one, a 10 millimeter long all-pin is placed vertically in front of a concave mirror. A 5 long image of the all-pin is obtained at 30 centimeter in front of the mirror. What is the focal length of the mirror? Okay, so find out this. Find out what will be the focal length. Yes, anyone got the answer? Dharya, did you get the answer?
No, sir, one minute.
So we are doing the first one, right?
You have to do this one, second one, a 10 all pin. Long all pin is placed. No one is able to get the answer. Shubhansh? Shubhansh?
Sir, 1 second, sir. I'm doing, sir.
Yes. Aryan. Aryan. Aryan,
Yes, sir.
why do you write your such a long name if your name can be written just with 2 letters? Aryan. Isn't it?
Yes, sir. No,
So why you write your such a long name? Okay, just joking. Ah,
sir,
so
very
that
confusing question, sir.
very confusing question.
Like,
Okay.
I understood, sir. But
So it's V by U.
yes, sir.
Magnification is equal to V by U, which is also equal to height of image over height of object. And since image is formed in front of the mirror, so it should be it will be a real image. So see, just it should not be taking so long. You obtain your magnification which is equal to height of image over height of object. This should be equal to minus of V over U. Now see, the a 10 mm long all pin is placed vertically in front of a concave mirror. A 5 mm long image of the all pin is formed at 30 centimeter in front of the mirror. Since the image is formed in front of the mirror, so it must be inverted. Okay, so height of
Is the answer A, minus 30 centimeter?
okay, just a minute. You will get minus 5 over 10 will be equal to minus of V over U, V divided by U, which is 30 centimeter, negative 30 centimeter. Okay, so this minus and minus cancel. You get 1 by 2, so you get V equals to 15, negative 15 centimeter. Okay, so you got V as 15 centimeter. Now you can use U and V to find F. So it is 1 by F equals 1 by V plus 1 by U. So it is 1 by F. Focal length is focal length we have to find out equals to 1 by negative 15 plus 1 by U. So U is negative 30. So this we write as negative 2 by 30 minus 1 by 30. Negative 3 by 30, which is negative 1 by 10. Got it? Is there any answer? Is negative 1 by, oh, there is no such answer. Then
Sir, why would the magnification be minus 5 by 10?
yeah, the magnification would be minus 5 by 10. The reason being it's a real image. See, the image is formed in front of the mirror.
Okay.
Okay. So the image which is formed in front of the mirror is real image. So V should also be minus 15 that we have got. Since it's a real image, so we've got V as negative 15. So why none of the options comes to be correct? Okay, got this answer? I think where are we going wrong? 150, negative 15. Everywhere it seems to be correct. So why is it wrong? Focal length we are getting is negative 10 centimeter.
Sir,
Sir, the options can be wrong.
Oh, just 1 minute. A 5 mm long image of the all-pin is formed at 30 centimeter. So image distance is given as 30 centimeter. Okay, this is we were wrong. So we have to make it V by U. So negative 30 over U. So
sir, the units are different, sir.
where the units are different.
Sir, 10 millimeter.
Oh, yeah, this one is also. So doesn't matter. Even if you are taking it's just the ratio. The magnification is just the ratio. The height of object is also in millimeter. Height of image is also in millimeter. So it's just a simple ratio. It will be correct. Okay. You just used to use minus V by U. So if you use minus V by U, So
Sir,
it's
then
minus
income
of
is minus 60.
minus of minus 30. So minus and minus cancel, and you have one more minus left. So you get you get as 30 or 300 over 5, a negative 300 over 5, which is negative 60 centimeter. Okay, now you can use the formula. Now you can use it to find out F. So you get 1 by F equals 1 by V plus 1 by U. I got now 1 by F equals to V is 30, so you get 1 over minus 30 plus 1 over minus 60. So you get minus 1 by 30 minus 1 by 60. The LCM is 60, and here you get negative 2, negative 1. So it's negative 3 by 60. Negative 3 by 60 is negative 1 by 20, and hence focal length is equals to minus 20 centimeter. Got it now? Yes. So you can just do the questions which I have sent in the group. All these questions you can try to do in which I have sent. Okay. Okay. Bye all of you. See you again in next class. All right. I'm just ending up the class 5 minutes earlier due to some work. I need to end it right now. Okay.
Okay, sir.
Okay,
Okay.
sir.
Bye.
Bye, sir.
Thank you, sir. Bye, sir.
Bye.